All right, Mr. Ahmed here for 2.2. Goal for today is to use inductive and deductive reasoning. And the first thing we have is a couple definitions. A conjecture is an unproven statement that's based on observation. So like I might observe that the past 3 days have been cold, and then I could make a conjecture and say it's going to be cold again tomorrow. All right, so it's not really proven. It's based on patterns and things that I see. And it's a guess that we can use that we could then maybe try and prove. So when I make a conjecture, I'm using inductive reasoning because I'm basing it off patterns, not facts. I'm going to list some examples. I'm going to draw a diagram and I'm going to see what I see. So you've probably done some problems like this, and it's looking at a pattern. And based off the pattern, we can form a conjecture to find the next item. So in this pattern, I can see that we went from 10 to 4. Well, the way I think I can get from 10 to 4 is to subtract 6. Similar manner, from 4 to negative 2, I'm also subtracting 6. And I'm subtracting 6. So the pattern is we're subtracting 6. The conjecture I could form is each number is the previous number minus 6. So the next item would be negative 14. So when I look at this one, for me to get from 1 to negative 2, I'm thinking, well, I'm adding 3. But if I add 3, that does not get me to 4, so that don't work. How else can I get from 1 to negative 2? Well, I think I could times by negative 2. And then if I take negative 2 times negative 2, that would get me 4. So I'm timesing by negative 2, and then I'm timesing by negative 2. So the pattern is multiply by negative 2. My conjecture, each number is the previous number times negative 2. It's a bad M for my times negative 2. So the next item would be negative 8 times negative 2, which is positive 16. So the next one doesn't actually list out my pattern for me. It tells me what I'm looking at. I'm looking at the sum of two odd numbers. So I'm just going to randomly add some odd numbers together. So if I think 1 plus, I wrote plus plus. 1 plus 3 is 4. How about 3 plus 7? That's 10. So odd plus odd, even. Odd plus odd, even. How about some negative numbers? Negative 3 plus negative 5 is negative 8. It's even again. So my conjecture is the sum of two odd numbers is even. We could try and prove that, but we're just going to leave it there. Next one, more of a geometric type problem. It says point S is between R and T. So I'm going to draw a diagram. S is between R and T, so that's a segment. R, T, S somewhere in the middle. Now I cannot assume that these two are equal in length. So really the only conjecture I can make is using our segment addition postulate and say that RS plus ST is equal to RT. That's really all I can assume. I cannot assume that those two are equal. So those are some conjectures. Counterexample is a means of showing that something is false. To show that a conjecture is true, I have to show that it's true for every case. I have to prove it's true without a reasonable doubt. For me to show something is false, I just have to give one counterexample. And a counterexample is simply a specific case, so just one example for which the conjecture is false. Okay? So easy example here by words would be like someone making the conjecture that LeBron James is the greatest basketball player ever. I could prove that false by saying, no, Michael Jordan is the greatest basketball player ever. So that would be my counterexample to prove the statement false, hence the conjecture, it would be false. So here we have a conjecture that says the sum of two numbers is always greater than the difference. So sum of two numbers, I'm adding two numbers. That'd be like something like 2 plus 6 is 8. And it says that it's greater the difference, so that'd be 2 minus 6, that's negative 4. I would say 8 is greater than negative 4, that proved it true. Now, can I prove this false? How about negative 3 plus negative 6? Negative 3 plus negative 6 is negative 9. Now their difference, negative 3 minus negative 6, is negative 3 plus 6. So minus negative changed to a positive, so that's 3. So this one here shows that it is false. This would be my counterexample. I've proven it false. I've shown that negative 3 minus negative 6 is greater than negative 3 plus negative 6. The statement or conjecture is false. Deductive reasoning now uses facts, definitions, and accepted properties and the laws of logic to form a logical argument. So we're going to talk about 2 laws of logic today. The first one's the law of detachment. It just states that if the hypothesis of a true conditional statement is true, then the conclusion is also true. So what we're saying here is if we have a given that states if a car is out of gas, then it will not start. I am told that Sarah's car is out of gas. So that means that the original hypothesis is true. Thus, the conclusion would also be true. And I could just simply say it will not start. The car won't start. I'm not going to assume that Sarah's going to go get gas. All right, I'm not going to make any other conjectures other than what this conclusion was. I know that the car won't start. Only reason why I know that is because it's out of gas. If it's out of gas, it doesn't start. So the only conclusion I can make is that it doesn't start. Another one says, if you have 2 segments that are the same length, then they are congruent. So 2 segments, same length. This says BC is equal to XY. These are 2 segments that are equal. If they are equal, they have to be congruent. So I would state that BC is also congruent to XY. Okay, so I'm just stating that they're congruent. Went from equal to congruent because I knew they were equal. That one's a little bit trickier. I'm going to do one more. If, this is my given, it is raining, then I will go inside. It is raining. So what do I know based off that? The given is, if it is raining, then I will go inside. It is raining. The only thing that I can state is that I will go inside. I don't assume anything else. I don't go inside to eat. I don't go inside to go play a game. I don't say who went inside. It's just I will go inside because that is all that I knew. It is raining. I will go inside. I could have changed this name to a Sarah instead of an I. So then we would be able to assume that Sarah would go inside instead of I. All right? So just take what it tells you. And lastly, this is a more challenging one, the law of syllogism. The law of syllogism states that if we have two true conditional statements, wherein which one of the hypotheses matches the other conclusion, so both we have a Q and a Q, so they say the same thing, then I can afford to make a new statement by matching the unused hypothesis with the unused conclusion. So if P then Q, if Q then R. So Q and Q matched up. I highlighted those in orange. They were the same. So since they were the same, I could form a new statement by saying if P, then R. All right, so we're going to look for something that matches out of our 2 statements. So in this diagram, it says if you get a job, then you will earn money. If you earn money, then you will buy a car. So the common theme is you will earn money. You earn money. Those say the same thing. So since those say the same thing, I can now form a new statement by using the other 2. If you get a job, then you will buy a car. And I don't assume what kind of car, I don't add anything else, I just say what I can match. And let's see here. If a polygon is regular, then all the interior angles are congruent. If a polygon is regular, oh, there's the match. If a polygon is regular. If a polygon is regular. Now here's the thing, those match, but they're both hypotheses. So since they were both the hypothesis, I cannot use the law of syllogism, so I can't write a new statement. Can't use the law of syllogism. One hypothesis does not match the other's conclusion. So I can't do anything. And that's all we got for today. Have a good one.